by diminishing the soil function. We'll talk about that, continue on our journey here. And I think a majority of the reason for this is because as I walked away from college, 8 years of school, for some reason I think maybe I ate the books or whatever, and I thought maybe I should have had more of an ecology-based background, because what I love about ecology, it focuses on the interconnectedness. Who would have known that these microorganisms are so deeply connected with the cow, with us as a human being? In fact, all of us today had contact with these organisms in a way, because they're the ones that provided the food and the nutrients, and maybe some of us had lunch today. These organisms are deeply connected with the whole ecosystem. One thing I want to mention here, these organisms are responsible for helping complete the water cycle. To me, the water cycle is not complete until the water goes into the soil pores, into the aquifer, and from the aquifer to the river, and from the river to the lake. These are deeply connected. That's why another thing I like studying is quantum physics. People that study quantum physics understand everything's connected, and it's all one. This slide I got from a very respected farmer throughout the country. His name is Joe Salatin. They wrote a book on, his farm was featured in that book called Omnivore's Dilemma. When I was speaking at a grazing conference with him, he asked farmers, is it farmers? The problem with us is we focus too much on nature's dissimilarities instead of our similarities. And what he's saying here is, he asked a group of farmers, he says, farmers, I want you to tell me which is my farm in Virginia. And in Virginia, I get 31 inches of rain, and I want you to tell me which farm is Africa. And the majority of the people that respond get it wrong. In fact, I got it wrong myself. On the lower left is Virginia, and the upper part is Africa. But here's the teaching moment that he was trying to say, is that we need to focus on nature's similarities and not our dissimilarities. One of the nature's similarities that's ubiquitous through the planet is the power of diversity. And we're going to talk about how incorporating manure and utilizing the power of cropping diversity and what kind of impact it does. And we'll talk about that. First thing, one of the things I do with this PowerPoint that I show with landowners, I tell landowners that it's our physical and chemical and biological disturbance diminishes these ecosystem processes. I tell farmers, our first thing we should do is when we get up in the morning, instead of saying, well, what things I have to fix on the farm, you should be saying, how much solar sunlight can I catch today? So I tell landowners our #1 job is to capture as much solar energy as possible and make sure that our farm, that the water cycle is functioning properly in our farm. As we have seen, tillage can diminish the water cycle. And one of the other things that's very, very important is the biocommunity dynamic cycle. This is where all the organisms, the connectedness of all the organisms and how the bottom biology affects the biology on the top of the surface. And the other one we talk about is the biogeochemical nutrient cycle. The biogeochemical nutrient cycle, I did not know about that until about 2 or 3 years ago when I started hanging around and reading lots of ecology books. If you look at a lot of our production agriculture books, you will see the term biogeochemical nutrient cycle. You see nutrient cycle. I like using biogeochemical nutrient cycling better because 75% of nutrient cycling is biological, then it's geological, then it's chemical. To me, that gives a clear context of who's doing what in the system. This slide shows the drillosphere, the Rhizosphere, the porosphere, the detritosphere, and the Rhizosphere. These spheres work together, but yet they work separately. The drillosphere is the warm sphere. The detritosphere is the residue sphere. The porosphere is the pores where these aquatic creatures, like the nematodes and the bacteria, live, cilia, and all the other critters. Our soils are subaquatic systems. These spheres all have to be intact. This hierarchical approach to understanding soil function was presented by Dr. Baer, Coleman, Grossley, Hendricks, and Odin back in 1995. Excellent read. Now, we're going to talk about manure. I look at manure as food. To me, manure is food. It's a resource for the soil microorganisms. It's an energy source. There you go, my high-power graphics showing, there's my cowpie is not there, but as soon as that cowpie hits the soil, you'll have these organisms feeding on that cowpie, and it's what the organisms do with that cowpie. That's amazing. They use it as a food substrate, and I'll talk about that. Who would have thought that cow manure has 1,611 kilocalories per kilogram of energy in it? Not only including that it has thiamine in it, it has calcium, it has an inoculum of bacteria, protozoa. It's a perfect food. Great energy source. It'll always excel over chemical fertilizer. Problem with manure is the way it's attained now. As you can see in this massive feedlot, the manure in these type of systems have large amounts of phosphorus and salts, and you get more copious amounts of manure in this type of system versus this type of system. The phosphorus is not as high in that type of system, and it has not as many salts in it. What are the benefits of manure? Simply stated this way, manure is an energy source for the microbes. It's the microbes that reduce the bulk density. It's the microbes that increase the organic matter. It's the microbes that increase aggregate stability and the soil organisms. They're the ones that reduce soil toxosis. They increase buffering capacity. They also increase the chemical activity. It's what the microbes do. They're the ones use manure as that food substrate to improve the physical, chemical, and biological part of our soils. They do everything. So manure is the preferred food substrate versus chemical fertilizer. Here, this photo here, I will show that what happens when, one of the things we have to be concerned when we use too much manure with lots of P in it, a lot of salt, you can reduce over-application of chemical P, or too much just plain the elemental P salt. You get over 100 parts per million. You can reduce the mycorrhizae and also overgrazing, and diminishes that. So does tillage, and so do fungicides, and diminish the vascular arbuscular mycorrhizae. And this mycorrhizae are needed in our plants, needed by plants. They create this symbiotic relationship. It's the mycorrhizae that make phosphorus available, so the bacteria make phosphorus available. Without this relationship, it would be more difficult to bring up zinc and some of these trace minerals. So mycorrhizae are needed. More than 80% of our plants are mycorrhizal. I also want to show this picture. As you can see, at one time I used to mow my lawn like this, like most everybody. Now I mow my lawn like this because I want to maintain, get a better rhizosphere. My neighbors tell me, Ray, you're just lazy. You don't want to mow your lawn. I said, you don't understand. I'm trying to build my rhizosphere. And they said, sure, Ray, you're just lazy. Luckily for me, in my subdivision, I have an acre and a quarter. I can actually have cows or a pig in the front yard and not make it an issue. But the whole point I wanted to talk about here is very, very important for us that we maintain that rhizosphere, because that's where all the organisms, and that's where they capture, that's where these organisms feed. Next one here, I want you to take a look. I believe this is the fertilizer bags from the 21st century. I tell our landowners we want our nutrients sequestered in the bodies of the cytoplasm, the bacteria, and we want it in the cytoplasm of a plant. And the only way we can do that, the more we have a living root there, these organisms will grow by the billions and feed there. As we apply our manures or fertilizers, we want those nutrients to be sequestered. As we're speaking, soils are mobilizing and mineralizing continuously, and they can do this down to temperatures even to below -5 degrees. Of course, it's diminished by quite a bit, but the point is we want our nutrients stored in the cytoplasm of the bacteria or the cytoplasm of a plant. Kind of a little commercial break here. I wrote this little handout here. Leslie has it there as a PDF file. It talks about manure's energy and the benefits of manure and what the soil organisms do with manure and how they build the soil structure and help increase soil health. Like here, I really like this picture because it kind of shows how carbon is very critical. In the last 6 months, I've come to the conclusion that I think the most critical element for our soils is carbon. A lot of people emphasize N, P, and K. To me, carbon is the driver of those nutrients. It's the energy. It's the energy engine for all those other nutrients because here is the microbes get fed from the crop residues, from the cover crops, from the root exudates, animal manure. You can see on the soil on the right, it's much darker and humified versus the one on the left. This shows the same as a 20-year study with a similar tillage intensity. So to me, it's all about carbon. To me, carbon is the most important aspect. And as we love diversity in food,